Okay, let's see here. I'm going to zoom in there. That looks pretty good. Okay, what I'm going to do before I do talk about tangent, let's talk about doing the basic equation, but now this isn't a special angle. This isn't one of the values that we recognize on the unit circle. Okay, so let's see how we do this. And what we're going to need is we're going to need our calculator, because we're going to have to use the inverse trig function. Okay, so I'm going to draw out my unit circle. And now the sine here is the y-coordinate, and this is a positive 0.7. So I'm going to go to my y-axis here, and maybe about right there you'd have like positive 0.75. Okay, so what that means is you have a point over here where the y-coordinate is 0.75. I have no idea what the x-coordinate is, but the y-coordinate is 0.75. And then you'd have a point over there as well. Okay, and they're both going to have that y-coordinate equal to 0.75. So I could do this, question mark, 0.75. And over here, this would be like negative question mark, whatever that number was, 0.75, right? But these would be two places where the y-coordinate is 0.75. Okay, now the thing is, I don't know what angle that is, and so what I'm going to do is I'm going to use the inverse trig function, and I'm going to do sine inverse of 0.75, and that's going to give me this angle. So now when I go to my calculator, I'm going to want to make sure that it is in radians mode, and it is. So you always want to check that. So when we do our homework, we're going to want to do it in radians. And so I go second sine 0.75, and when I do the inverse sine, that gives me this angle, and that angle is 0.848. We'll round all these to, we'll just do the 3 decimal places. That's good enough. Okay, so this angle here is 0.878, I think. Oh, no, 0.848. 0.848. Okay, so that's this angle here, and that's one of my two angles, right? 0.848 plus k times 2 pi. These are all the rotations of that. Okay, now I also have this angle over here, so the question is, what is that angle? Okay, excuse me. The way that you're going to find this is actually like this arc here, and so this is pi, right? This whole thing is pi, or you can think of this arc on the unit circle as equal to pi. And so what I'm doing is I'm backing up to this point, and the distance I'm backing up here is equal to the distance I went here. So to get this angle, I'm actually going to take pi minus 0.848. Okay, I went here, so now I'm going to go 0.848 this way. And so take my calculator and take pi minus 0.848, and I get 2.294. Make sure I got that right. 294 when I round to 3 decimal places. So this would be x equal to 2.294 plus k times 2 pi. And those would be the two solutions. So it's very similar to before, but you don't recognize these angles as special, angles on the unit circle, so you're using the inverse function, trig function. And you know what, I didn't write it up here, but you're using the inverse trig function to get the one angle that you can get with that function, and then you can use it again over here, in this case taking pi minus that. Okay? Now let me show you, let's do one with a sign of a negative value. So we'll say sine x equal to, let's just say negative, we'll say 5/9. Okay, so it can be a decimal, it could be a fraction, but this is not a special point on the unit circle. So 5/9 is a little more than 1/2, right? And I don't know, I would say maybe right there. This is a negative 5/9. Okay, and so you got these points on the unit circle. One would be over here. You'd have another one over there. Okay, now let's do the sine inverse of negative 5/9. Okay, and see what we get. Okay, sine inverse of negative 5/9 is, and notice we get a negative value here, negative 0.589 is what I get here. Okay, so if you remember, the sine inverse always gives you an angle between negative pi over 2 to pi over 2. Okay, it'll give you one of those angles. And if you remember, cosine gave you 0 to pi. It'll give you one of these angles, the inverse cosine. But inverse sine is negative pi over 2 to pi over 2. So what this actually gave me here was this angle, right? That angle there is negative 0.589. Okay, now let me say something here. If you did, because you would have this angle plus all the rotations of that, so if you did negative 0.589 plus k times 2 pi, and you did this as one of your solutions here, okay, and I'm writing it over here because this is not the way I normally do it. If you did it this way and then you found this angle over here and added that one, that would be fine. You wouldn't get it wrong. But you know what? I have OCD and I like to get the angles between 0 and 2 pi. So I like to get this angle and I like to get that angle. And then I like to put them in that order. I like to have this angle first and then that angle second. And it's just, to me, that's so nice and orderly. You get the two angles between 0 and 2 pi, and they're just all in order. That's just the way I like to do it. Okay, so what I do, I'm using the fact that this is negative 5.89 there, okay, and I'm going to use it to get these other angles. So I'm really going this distance from here to here is like pi plus 0.589, right? I'm taking pi and then I'm adding that arc or that angle. Okay, and what do I get? Pi plus 0.589, and that's like 3.731 when I round. Okay, now how do I get this angle? Okay, well, if you go all the way around, that's 2 pi, and then what I need to do is I need to back up the 0.589. So I'm going to take the 2 pi, and then I'm going to go back here 0.589. Okay, so I would do 2 pi minus 0.589. And that gives me 5.694. Okay, so this one would be the 3.731, and this one would be the 5.694, and those would be the two angles that I would use, just because, you know, I have OCD, plus k times 2 pi, and then 5.694 plus k times 2 pi. Okay, so that's how I would do it. Okay, if you had this angle in place of this one, that would be okay, because you would have this angle and all the rotations, and you would have this angle and all the rotations, and you would get the same set of angles for your solution. Okay, So now if you if you put this angle in place of this one, right? If you took that one out and you used this one, that wouldn't be right because you would be generating that same one twice. So you got to have this angle and this one, either the negative one or the positive one there. Okay? But this is the way I like it. If you want to make me happy while I'm grading your paper or whatever, I love to see it like that. These are the two angles between 0 and 2 pi. And they're nice in order, and that's the way I like it. Okay, so that's the sine. Let me do a cosine one now. And what I did is, just to show you a little something extra, is I wrote it out a little bit different, and this is going to be just fine. Here, I'm going to be able to solve it. This is basically a basic trig equation. I just need to solve this whole thing for the cosine x, kind of like a linear equation. So I subtract 2 from both sides, and I get 5 cosine x is equal to -1. And then I divide both sides by 5. And then I get cosine x is equal to -1/5. Okay? And so now you see I have a basic equation. So you can take equations that look a little more complicated, but they're basically a basic trig equation. You just have to solve for the trig function like that. Okay, so now let's solve this. Now we're dealing with cosine, so I'm dealing with the x coordinate now, and so the x coordinate being -1/5. So I'm on this side, and I don't know, maybe right there is -1/5. So you got an angle up here, right? And then you have another one down here. Okay, so you have this one. I didn't draw that very good. And you have this one down here. So you got this angle and that angle. Okay, now when I do the inverse cosine here, so if I do cosine inverse of -1/5, it will give me this angle, because the angle is always between 0 and pi. So for the inverse cosine, it'll give me an angle between 0 and pi. Okay, so I'm going to take this, and I'm going to do inverse cosine -1/5, and it gives me 1.772. So 1.772, and that's this angle up here, 1.772. It gives me this angle. Okay, and that's one of them. 1.772 plus k times 2 pi. And so we're good there. Now I need this angle down here. So how am I going to get that? Well, this arc here, or this angle, however you want to think of it, is this distance is 1.772. So I got 2 pi up here, and I'm backing up that distance. So I'm taking 2 pi, subtract 1.772. Okay, so I'm gone 2 pi, and I'm backing up this same distance. And that's going to give me the other one. So 2 pi minus 1.772, and this angle down here is 4.511. So that's this angle down here, 4.511. Okay, and that's my other solution here, 4.511 plus k times 2 pi. And there's the solution here to this equation. Okay, it's basically a basic trig, but now I got cosine, and with the cosine, okay, you're going to get one of the two angles between 0 and 2 pi. You just have to find the other one. And it works the same way. If this was a positive number, it'd be over here, and the inverse cosine would give you this, and you take 2 pi minus that, and you'd get the one over here. You'd get the two angles. Okay, so that is solving a sine or a cosine where these are not special angles on the unit circle. They're just any angles. Okay? And now, the next video, we'll look at solving trig, both special angles and just regular ones.